prepared some easy questions for you. As long as you did what I told you, you got, 3 questions, so that's 2 points each, that's 6%, 6 points, however you wanna look at it. So that it did have a built-in curve, but nice distribution, you with me? So thank God that's behind us. You guys did pretty well. We had, as you can see, most grades overall were like in that B area. A's were not far behind. C's, many of the C's were pretty damn high too, you with me? So good for us, I'm happy with that. I'm not doing an additional curve. I think the 6 points freebies was their padding. I guess I didn't even need to do that, but I'm fine with it, I'm happy with it, and I appreciate your patience with me because I don't want to do that, but I think that was better to get another test out of the way. Okay, so reach out to me, we can go through it if anybody wants to. This graph, this distribution, I think I threw in that exam 2 kind of module, call it what you will, where I posted the exams if you want to take a look at it. It's online on Folio. It just downloaded in kind of a funky way there. So is everybody okay with the gist of that? So, you guys are really communicative today, if that's a word. It's spring break next week, did you know that?
Mm-hmm. I'm going home.
Did you know what the government's about to do to us again? The man has declared that we're gonna lose an hour of your life. Just gonna, willy-nilly, I'm gonna take an hour, I'm gonna make you get up early.
I was going to talk about like taxes or something.
You hear me? I think it's this Sunday, isn't it?
Yeah, it is.
Oh, I hate time change. And for the next 7.5, 8 months or whatever, I'll tell you what, you people will get up Saturday at midnight, you scramble and turn all your clocks. I don't do it. I don't change one freaking clock. Even my computer, I go back and I tell it I live in Central Time. Because it pisses me off. It is a scam, it is bad for your health, it causes accidents, heart incidents, stress, strokes, all that rises. We need to go back to normal time, standard. You're gonna hear about a couple senators that always pass a sunset bill or try and get it, brought to Congress and passed through. But they just wanna stay on daylight savings time. And don't even tell them you like it more. You don't care about this. You don't seem to be. This is what's happening since COVID. Nobody seems to care. As long as you got your little sociables, you don't care. Alright. I'm done. Soapbox, sorry. You ready to get started then on your stuff? Yes. Look, the nice thing about this, let me just be honest with you. No ringer questions. Your average on the next test will probably have a good chance at staying in that, high C, low B range, just as a large group. The digestive system, there's a lot to it. You gotta spend a lot of time on it, but I think we all have a basic foundation understanding of it. And it's kinda, it's straightforward. I mean, there's a bit of physiology, there's a lot of enzymes, we're gonna talk about, biochemical processes and things of this nature, but, it's doable. And so your next test will probably be about 60% on this chapter 23. And probably closer to 40% as we skip over to the kidney, which would be the second component of your next test. So digestion and kidney. So I guess what I'm saying to you is, even though this is kind of straightforward and stuff, in most places, just make sure you're swallowing it. Ah! I could have said like digesting it. All right, so organs of the digestive system. So there's 2 posts that I have, and you can see I've gone back to kind of a PowerPoint layout for this, but in my own words. So our organs of the digestive system are organized into 2 basic groups, either the alimentary canal, which I'll probably say as often as the gastrointestinal tract. So this is basically from your mouth all the way down, right? Esophagus, stomach, small intestine, large intestine, all the way through the other end of the anus. Okay, that's the GI tract. So if you see GI here and there in my notes, if you will, or if I say alimentary, that's the straight passageway through. Okay, and then we have all these accessory digestive organs, and I might have to devigify a little bit here so you guys can see a little more So, I mean, you can talk about your teeth, dentition, I guess you could even throw in your tongue, I'm not trying to be comprehensive there. But your liver, your pancreas, your salivary glands, you with me? We have a lot of other organs that are not part of the tube system, if you will, from beginning to end, that are contributing, that have pipes, that have ducts that come in, and they funnel in different concoctions of bicarbonate, or hydrochloric acid, or enzymes and proteins that come into the digestive system along the way at key intervals and help you break down all the foods that we consume. So we'll kind of go through this course, and forgive me, I'll see if I can't get a slide in time on here. So, you know, we're not gonna sit here and name them all, but we'll be looking at, you know, illustrations like this, different figures. You know, a lot of you were in lab, you guys will have a chance to see some of the more model-centric views of this as well. I paused very briefly because some of you, I think, previously had indicated that you actually, a lot of you are in my 15-week lab with me that's online right now. I think a number of you are in my lab that is running 7 weeks, just started yesterday technically. If you are, just so you know, they're gonna start harassing me for that intense verification. So they want you to have clicked on that and submitted. So if you are in my lab that just started for the 7th week, make sure you guys click on that. And tell your friends, because I don't want anybody kicked out for non-attendance. All right, sorry for the diversion there, but we're all part of the same team. Look, a laundry list, and a lot of what these first handful of 10, 12, 15 slides, a lot of it is just me kind of giving you broad brushstrokes. So when I show you a litany of things that you could characterize our digestive system, functions, characteristics, what does it do? These are not things you have to memorize, you know, one by one, but they make sense, right? I mean, first of all, we gotta manipulate food. We gotta find food. You gotta go to the food line. Are you with me? Go shoot a squirrel or something. It's just horrible. But nevertheless, you're catching game. You're buying the lettuce. You're going to Zaxby's. You gotta put it in your mouth. You gotta manipulate it. You gotta ingest the food. So if we really get specific and set aside all the hands and fingers and toes and things, you gotta manipulate it with your lips, the tongue. You've gotta chew it. You know, you gotta get it going, basically. Propulsion, if you hear that word, it's not one I'm gonna say over and over, but think about, I mean, we got gravity that's gonna help us when we like swallow food. And that can be after swallowing as we go down to the digestive systems. Gravity can kind of help things move. Propulsion generally implies muscle contraction and relaxation. So we're gonna see layers of smooth muscle primarily, right? Typically a couple of layers, we'll talk about these in a bit, but they're gonna take turns contracting and relaxing to move food generally in one direction. And so you can say that's propulsion, part of the characteristics of the digestive system. Mechanical and chemical digestion, I say breakdown, you know, to break down food. Mechanically is like chewing your food with your teeth, grinding it up, physically tearing it apart, manipulating it with your tongue, contractions of the stomach and small intestine, that's kind of mechanical churning, that's important. But then chemically, we got a dosage of different acids or different, you know, alkalinities, so we're gonna see different swings in pH depending on where we are. That's gonna allow certain enzymes along the way to work better. The enzymes are gonna start to attack the, you know, biochemical molecules, organic molecules that we consume. So we think about carbohydrates, you know, we think about fats, lipids, we think about proteins, even DNA and RNA, nucleic acids. These are the things we gotta chemically break down into their little constituent bits so we can absorb them across the inner lining, or we'll say mucosa, which is just epithelial tissue of the small intestine primarily. Okay, so we're gonna try and absorb these nutrients into the blood, into the tissues of the body, and that's gonna require a lot of chemistry behind it, so we'll get into this a lot too. Absorption, I kind of tied that in. We're gonna try and move materials microscopically, pull them across the intestinal wall, get them into like the bloodstream, pull them into the tissues so they're not lost as waste. And of course, we're gonna eliminate a lot of proteins, fibers, things of this nature that we just were not able to digest properly, form feces and get them out of the body, obviously. All right, so when you're thinking about this, you know, region of the body, and I'm gonna just talk about it as the abdominal pelvic. So abdominal cavity, we would normally kind of think of that as primarily where the digestive system kind of mainly resides, if you will. But the pelvic too, because we're actually gonna see that, a portion of the colon down into the rectum kind of dives down towards the anal canal, the anus. So probably should consider both. To be honest, up here, this is not abdominal pelvic, right? So I have to have a throat, the pharynx we were talking about, that is going to, when we swallow food, lead to the esophagus, right? That's then going to take it down the stomach. So we got a tube that's traveling through different cavities to get to this region. But there you go. So we have parietal and visceral serous membrane, S-E-R-O-U-S. It's not anything you have to worry about, but these are the slippery little membranes like the pericardium, like the pleural membranes we saw around the lungs. We've got a kind of a two-part slippery layer, and we're going to use the same kind of descriptive terms, visceral and parietal. Parietal would be a membrane that we encounter first as we're in this region of the abdominal pelvic area and we're headed into some target organ, let's say the stomach. So you would encounter that parietal layer. Now, there is a fancy term here we call it the peritoneum. Okay, so the peritoneum instead of pericardium, like we might have called it around the heart. Peritoneum is typically what we're describing, these two-part visceral and parietal membranes. Okay, peritoneal layers, peritoneum, visceral peritoneum, parietal peritoneum if you prefer. Remember, there is a little bit of a cavity between anytime you have these little slippery membranes. So the peritoneal cavity would be between the parietal and the visceral, okay, peritoneum or peritoneal layers. And the visceral would lie right on the surface of that target organ that you were interested in, like the stomach. So the visceral peritoneum would be right there on that outer, kind of fused to the outer edge of your organ of choice. Additionally, I say the peritoneum here, we see folds of peritoneum. So, we describe the peritoneum as having a visceral parietal, and that's, let's say, we go to the stomach, and that's what we see. But when you kind of zoom out, you're going to see the same folding membrane, peritoneum, just kind of extends in between organs and kind of goes back and forth, kind of like a wrinkled carpet. When your dog runs across, everything kind of gets cinched up. And it makes these kind of folds and ripples. And these can form what are described as a mesentery. So mesenteries are just kind of multiple folds of peritoneum that are maybe not directly surrounding an organ of choice, but they actually do kind of drape over multiple organs. And mesenteries can help suspend organs. So when you do a cartwheel, stand on your head, right? Your organs aren't twisting and flailing. The mesenteries can kind of help secure them. Mesenteries are nice because these kind of folds of peritoneum, and I'll pull down here so you can see it, or a little bit of it. So this is what we're kind of talking about. This would be some of the mesentery. And there's several of these in different areas of the abdominal pelvic region. You can name them, and I'll name a couple, not every single one. But these are covering and draping over the organs, apart from just saying an organ may have a parietal and visceral layer, it may indeed, but then you find these folds outside of it. But this is where you would find like blood vessels, lymphatic vessels, nerves that kind of crisscross, run within the peritoneum. So peritoneum secures organs in place, and the peritoneum can also provide this kind of route, if you will, for blood vessels, nerves, etc., to go back and forth with different digestive organs. So there are a couple here, and I don't know if it was above or below. Yeah, so mesenteries with unique names include the falciform ligament and greater omentum, ... There's a lesser omentum, there's a greater omentum. I mentioned a couple here. So let me see if I can kind of point this out. I do this because in lab, you're asked to consider some of these a little bit too. It's probably not going to go well, but if you, I don't even think you can really see it. I've tried to zoom in a little bit. Two mesenteries that go by their own name. Some mesenteries are just so damn important that we've called them something specific. You with me? One is the falciform ligament, and you can't even really see it, but we'll see the liver down the road again and again. We have a large right lobe to the liver and a little smaller left lobe. So I'm looking from the ventral view, and I see a stripe kind of right between it. This is called the falciform ligament. The falciform ligament runs between the big lobes of the liver, and it is not a true ligament of tendons and, it's not a ligament in terms of a bunch of collagen. It's really just a bit of folds of the peritoneum here. But it does help kind of secure the liver in place. And falciform ligament, we'll see when we get to the liver, it's a clear kind of anatomical boundary between the two big lobes anteriorly. And then we have one that I work on a lot with beer. You're not old enough for beer, but proof, God wanted us to be happy or something. Possibly a Benjamin Franklin quote, maybe not. I don't know. I like it. Here's proof that God wants us to be happy or something. If you're married, it's real true. But nevertheless, I work on my fatty apron. You with me? Your greater omentum, and it's not really shown in this image. We may see it a little later, but we have a mesentery. It's called the greater omentum, and it drapes over kind of between the colon and drapes over a lot of the small intestine coils. And so it's just these folds of mesentery, what we call the greater omentum. Not really shown or highlighted here, but the greater omentum tends to collect adipose cells, fat cells. You with me? So this becomes your muffin top. This becomes your beer belly. You with me on this? This becomes a sign of health. Are we going into winter because I'm beefing up? You with me? Or is it getting hotter? Oh, piss, I've done this wrong. Well, the point is, that's your storage site. You with me on this? This is where we tend to collect fat. So greater omentum, we'll maybe see it illustrate a little better. If you're in lab, you'll have a chance to see it in this glory. I'm not trying to get it, oh my God, sorry. I'm not trying to get into all of this so in particular, but I just do give you two. So these would be the only two that I might describe on a test and ask you guys to recognize them as mesenteries that are just unique enough that they can describe with their own terminology. Look, let me just point out though that even though we spent all this time on visceral and parietal peritoneum and all the mesenteries, some organs, some digestive organs, or even parts of a digestive organ, like a portion of the small intestine, may actually sit outside of the visceral and parietal peritoneum. And if you do that or sit behind, you may be described as being retroperitoneal or partially retroperitoneal. So the rectum is retroperitoneal. You don't have to write these down. The beginning of the small intestine that comes off the stomach, so this would be that proximal section, about 8 or so inches. It's called the duodenum. You don't have to write that down, but that's actually retroperitoneal. Okay? So if you're not wrapped by that, you may hear that term. I'll mention them as we go, but I'm not trying to give you 7 organs you've got to label on the test. You with me? Okay, real quickly, I'm not really harping on this. I don't see a lot of this as being testable. I'm just hitting you with the big picture. So I'm not trying to tease apart all the blood vessels because I think we'd have to go to the glossary, the illustrations, the labels on the test. I don't really want to go that far. But the digestive blood supply, we're going to have branches from the dorsal aorta that's kind of diving down through this abdominal pelvic region. And there's blood vessels that branch and go to key digestive organs. The only term I'd like you to recognize is the splanchnic circulation. So for test purposes, that is this cluster of blood vessels, and veins would be returning the blood from these organs. But splanchnic circulation would consist of kind of the following key branches. I don't think I'm going to ask you to name these branches on a test. You okay? But I would like you to just know splanchnic would be the blood supply that's coming, into the vena cava from veins and going from the aorta into the artery or into the organs. That's all I'm asking. But technically hepatic, so we're going to look at some blood vessels in the liver. You okay by the way? Or okay by the way, and you all right? So I got 2. Got you covered. You're welcome. So in the liver, hepatic, hepatocytes, hepatic, we're gonna talk a lot about liver terminology in a while. That'll make sense. Gastric, of the stomach. Splenic, I know what you're saying, spleen, no, that doesn't digest food, that's lymphatic. It is, but it's just a branch in this region, no big deal. Mesenteric, a branch that typically is gonna divide and send vessels in and out of the intestines. So you don't need to name all of those as a list. I'm not gonna get into it right now in any detail, but we will name some blood vessels as we go further. And I think probably we're going to see a good bit of this is when we get to the hepatic portal system, hepatic for liver. So without worrying about the anatomy, I'll define this later, but here's the deal. You and I eat food, yum, 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 we swallow it down, it goes to the stomach, we dose it with acid, we dose it with enzymes, saliva dosed it with enzymes as well. After some hours, it goes into the small intestine. Across the small intestine, we're trying to absorb across little finger-like projections, microscopic little projections called villi, lined with epithelial cells. We're absorbing nutrients, we're getting it into the bloodstream. We have veins that are gonna leave the small intestine, and we'll name them later, but they're carrying loads of nutrients, amino acids, simple sugars, all these things that we just consumed and absorbed. We send that through veins to the liver. The veins going into the liver will branch into little capillary networks inside the liver, and the liver cells, called hepatocytes, get to gobble up those little building blocks of sugars and amino acids, building blocks of proteins, and the liver can kind of play around with what it needs. Boy, that was a lot of Twinkies you just ate. It's a hell of a lot of sugar. Let's take some of the sugar out of the blood, the liver says, and let's link it together into a big polymer carbohydrate that we call glycogen. And we can store it for a later day when you're not so glutton filled. You with me? And they can use the amino acids to make all those clotting proteins. So we'll get into that, but that's what the liver cells are doing. But the veins coming in branch to capillaries inside the liver, which then drain into veins, which go back to the vena cava. So the liver is a processing center before we send the blood right back through the general circulation. So hepatic portal, a portal system characterized by like veins and capillaries drained by veins. So it's kind of odd. All right, I'll name all that later as we go. All right, so histology of the GI tract, 4 basic layers. Shh, ladies, this is too damn good. Histology of the GI tract. So basically what I'm saying is if you're in the esophagus, if you're in the stomach, if you're in the large intestine, right? If you're passing through these pipes, from inside out, you see the basic foundational layers, okay? Mucosa is the innermost layer. It is made of epithelial tissue. Now, most of what we're gonna find in the digestive system is simple columnar epithelium. So simple columnar epithelium are the elongated kind of column-like cells, simple single layer. There are a lot of little mucus-producing goblet cells that look a little more like a little flask-like cell that's nestled amongst all these columnar cells. These have the simple columnar epithelium, we'll talk about this in a little bit. They have little tiny apical extensions. They're not as elongated as like cilia. Remember we saw pseudostratified, ciliated columnar epithelium, like in the trachea and along the respiratory pipes. The cilia are a little more eyelashy, long. These cells, simple columnar epithelium, which is most of what we see in the digestive system mucosa, they have short, stubby little projections, but they're really dense like a shag carpet. We call these microvilli. And I'll define that, you'll see it written out. But I'm just saying, we'll get into this in a little more as we go. So we'll characterize this a little better, but this is the gist of mucosa. So secretes mucus with the goblet cells, that's what they're doing. Some of the cells, simple columnar epithelial cells, some are making hormones, H's, hormones, enzymes. This is where we primarily, though, are trying to absorb nutrients into the blood. And I'm saying, nutrient absorption, that really is small intestine. Damn, small intestine is 20 odd feet in length, so it's quite lengthy. And we'll get into that a little later. There are a couple layers that lie as part of the mucosa. You can see lamina propria and the muscularis mucosae plural. Let me go down here and let's see if we can look at this a little more. And I am sorry, I gotta back it out so we can see it. So let's say this is esophagus, the esophagus, or it could be the small intestine. Here's the lumen through which food passes. So this is obviously superficial outside, this is deep on the inside. So I'm saying that this layer right in here, right? This layer, that would be my simple columnar epithelium, that's my mucosa. Then I would have what's called the lamina propria. See kind of in tan in here, and we're gonna see that is kind of a loose connective tissue that just supports the epithelial cells. And you will see a little bit of glands, you will see little lymphatics and nerves and vessels that kind of crisscross through it. And then we're gonna have a foundation at the very base of the mucosa. So everything here is mucosa. The simple columnar epithelium of goblet cells, the lamina propria, loose connective tissue, and this maroon layer right here is a thin little band of smooth muscle. And it is still considered the mucosa. They call it the muscularis mucosae. Okay? So that is a band of smooth muscle, but it is still classified as mucosa. Everybody cool with that? All right, so once we move through this, we're gonna move into another thicker band of areolar loose connective tissue, and this is gonna be called the submucosa. And I see lots of blood vessels, lymphatic vessels, some nerves in here crisscrossing through it. So the submucosa is connective tissue, loose connective tissue, lymphatic vessels, blood vessels, nerves. The submucosa, we're actually gonna see a nerve plexus, but I'll clarify this in just a second. A cluster of little neurons in the house that kind of aid in digestion. Okay, so we'll look at the submucosa and add a couple thoughts to it in just a second. Then we get into layers of smooth muscle that are much more prominent than that little band of muscularis mucosae that we saw at the base of the mucosa. So now we're going from inside to outside. We travel through a little thicker layer of the submucosa, right? And then we see these what are colored maroon bands here of smooth muscle. So now we're into this region. And we're gonna see a couple of layers. I see a longitudinal smooth muscle layer, and I see a circular smooth muscle layer. So this is the muscularis. And if you wanted to just be as clear as possible, you might call it the muscularis externa, they like to call it, because you're trying to make sure people aren't thinking you're describing that little thin layer of the muscularis mucosae that we had passed a bit ago. I'm so lazy, I'll just say muscularis. If I say muscularis to you, I mean this would be the contractile smooth muscle that propels food through the digestive system. Quickly powers things like peristalsis, okay, kind of a one-way movement of food as it travels down. But we have an outer longitudinal band. The muscle fibers, smooth muscle fibers kind of run the length. Let's say if this is your intestine, my arm. So we have, this would be a little more superficial towards the outside, longitudinal. And then just deep to this, we would have a circular band of muscle that kind of runs in a circular fashion. So longitudinal and circular muscle layers, two layers typically of the muscularis or muscularis externa that contracts and relaxes to propel food down the way. So these two are what we normally are going to find. And SM, I'm sorry, just for smooth muscle. Help me, sometimes I sneak in abbreviations and I don't want them to confuse you a day or two later, you know, and I don't do the best job at clarifying. So longitudinal smooth muscle layer, circular smooth muscle. This would be the circular, typically right up against the submucosa. This would be the outermost layer. But in one organ, which is the stomach, we actually have a deeper or most deep layer, okay, that would run at an angle. So these are smooth muscle fibers that kind of run kind of at a 45-degree angle or obliquely. So we say this would be the oblique smooth muscle layer. Again, muscularis externa. And that would be the innermost, but you would only find that third layer if you're looking at the stomach. It's a very powerful contractile organ. And we get to the stomach, I'll mention all three of these when we're in the
in esophagus or within the small intestine, we're typically just giving them the 2. So I'll point this out again and again as we go. Peristalsis, you guys are familiar with peristalsis, peristalsis. Basically, these muscles are contracting and food gets moved along, typically down the path, okay? Typically kind of in one direction, kind of as if you're squeezing toothpaste from a half-empty tube, right? Kind of pushing it down in one direction towards the cap. Peristalsis is what we're probably more familiar with, but there is also contraction of these layers that can be a little more spastic, a little more unpredictable.